Right, so here we are at the Third Energy Kirby Misperton site. It's a gas pad that's been earmarked for unconventional shale gas extraction, possibly later in the year. And what we're here for is to change this. I'm Ruth Purvis and I'm a research fellow in atmospheric chemistry at the University of York, working with the National Centre for Atmospheric Science. So what we've got in here is a sample of air that was taken at 9:30 on Monday morning for a period of an hour. But what's interesting about it is we do this every Monday. So since January, every Monday morning, we've had a sample of air from this site. What we've got from taking these samples is a record for hydrocarbons of what's happening in the area. These can be affected by activity on the existing gas well, it can be from the agricultural surroundings, or it could be taken in from long distance and brought here by the wind. What this gives us is a baseline. And why is this important? Well, if the non-conventional gas extraction, or what's known as fracking, happens on this site, we need to know what the effect of that will be on the air quality. We can't know that unless we know what's happening here already and what emissions are here already. And so that is why the baseline is important. That's what it'll tell us. It'll tell us what's here already, and then we can assess the impact of fracking on air quality. That's us done then. Back to the lab.
Okay, so this is one of the samples that we've collected this morning, and what we do next is connect it up to the instrument using this tubing. This instrument can select different samples. From there, the sample is passed through to a water removal unit. So housed within here is a very cold block. The sample passes through that and all the water freezes out onto the surfaces. The dry sample is then passed into this pre-concentration unit. So the concentration of the hydrocarbons in each of these samples is very low in the atmosphere, and so we need to enhance those, and that's what this unit does. From there, it's then passed on to the GC for the analysis.
This is our comparison and calibration lab, so-called COSY laboratory. This lab supports all of the measurements we make out in the field and the measurements we make at our baseline monitoring stations. What we have here are a number of tanks of atmospheric gases, and we can introduce these gases through various bits of tubing into the backs of these instruments. This instrumentation never moves, and so we know it's correct. So if we have an instrument here and an instrument out in the field, and we bring the two together, we need to ensure that they are saying the same thing. The point about this process is that we're not making these measurements in isolation. They need to be linked to all of the measurements of the compounds all over the world, and we do this through a set of international standards.
Everybody breathes air, and we can't see what's in it. So I think it's really important that we have these monitoring stations and we have the research that we do, so we know exactly what is in the air that everybody is breathing. We're not working for the shale gas industry. We're here taking measurements for the public to understand any future impact of any activities that happen on this site.